Good afternoon. My name is Brian Welker, and I'm a Principal Product Manager on the Amazon RDS team. Excited to give you today a deep dive on Amazon RDS. Now, as a product manager on the team, one of my main jobs is to answer questions. And I get lots of questions. I get questions from support cases that people open. I get questions from our field account managers and SAs. I get questions over the RDS forum. So we have a community forum where we answer questions about the product. And I get questions from shows like reInvent. And so what I'd like to do over the next 50 minutes or so is to review a lot of those questions, answer some of those questions that I get constantly about using the service in order to help you use the service better. Just a show of hands, who's using Amazon RDS today in production? Okay. How about for more than a year? More than a year? All right. How about more than 5 years? Got a few there. Okay, good. How about more than one database engine? Using more than one? More than 4 database engines? Okay. Well, we've got some long-time users and some users that are using the service, so hopefully we'll get to a lot of those key questions. So for those of you who are using it today, you probably know that Amazon RDS is our managed relational database service in the AWS cloud. And you may not know that Amazon RDS was started back in 2009, one of the earliest services in AWS. And it was started by some folks who were running the Amazon.com database, the database that powers our e-commerce site, running one of the world's largest e-commerce databases at the time. And they thought, well, if the things that we've learned about running databases is that we can take that and apply it to our customers' databases. We can do the same things for our customers in AWS. And so they started the core of Amazon RDS. Started with the MySQL engine, and then over time, over the last 7 years, it's grown. We've added engines, we've added features, we've added the Amazon Aurora engine. So it's really grown. And at the time, it was sort of a novel idea. Why would we have a database service? I can just use compute and storage, and I can run my own database. But we really wanted to provide a higher level service that took some of the muck, sort of the grunt work out of running your own database. Things like provisioning, things like patching, things like scaling, backup and restore. These are things that if you have good DBAs, you have good engineers, you can build yourself, but they're really not things that necessarily add value for your company. And then we provide really these high availability solutions that I'll talk a lot about leveraging high availability. These are things that typically come in commercial databases at a very expensive price point. And we built them right into RDS. So from the beginning, you can take advantage of these. So why would you use a managed database solution? As I mentioned, we manage the muck. We manage the day-to-day grunt work of running a database. And that allows you to get more out of your teams, right? So they can build their apps, they can deploy their apps, they don't spend a lot of time tweaking the database. And really focus on the things that differentiate your solutions, not running a relational database. As I mentioned, we've built in high availability and cross-region, things like cross-region replication. So one of the benefits of being in the AWS cloud is that we have a global infrastructure. We can do things that are really challenging to do on premises. Being able to support multiple data centers around the world for high availability, for disaster recovery. So even if you're a small startup just starting out and you're provisioning your first database, you can take advantage of these features right off the bat. You simply check a checkbox in the console, and then you get a really available solution with that 99.95% really high availability. So the first thing you have to do when you're getting started with RDS is you have to pick your database instance. You have to pick your instance, you have to pick your storage, and that can be a daunting task. The first thing actually is to choose your engine. So we now support the what we call the EBS base. These are our 5 engines on the left that are based on Amazon Elastic Block Store. So 2 commercial engines we call Oracle and SQL Server. Obviously, those are products from those companies we just run as is. And then we have our open source engines, MySQL, PostgreSQL, and MariaDB. These are engines that we take the community distribution. We do a small amount of tweaking, but really we pretty much take them as is and then run them in the RDS infrastructure. So that allows us with these engines to really keep up with the improvements in the community. When those new versions come out, when those improvements come out in the community editions, we just incorporate those into RDS. Now, we do have our cloud-native databases. So our Amazon Aurora, that comes in both the MySQL compatible edition and the PostgreSQL compatible edition that we went GA with a few weeks ago. And those are built on the Aurora storage system. So instead of using Amazon EBS, they use a totally cloud-native, built from the ground up storage system that has a huge amount of benefits for durability, for scalability. Now, I would encourage you, for this talk, I'm going to talk about RDS broadly, but I'm going to focus on the EBS-based engines. If you want to know all about Aurora, there are lots of great presentations, deep dives into the Aurora storage system. Some of the things I'll talk about are applied to all of the engines, but I really wanted to talk about some of the traditional, some of our EBS-based storage engines. So the first thing you do once you pick your engine, and you know, many people pick their engine because they've got existing applications that they're running today. Sometimes they pick their engine because they want to move from, say, a commercial engine over to an open source engine. They're tired of paying licensing fees and they want to move to open source. Sometimes they're building new applications and they want to take advantage. So, you know, multiple people, you can take multiple engines, but once you pick your engine, then you have to pick your instance type. There are currently 27 different instance types. We support a subset of EC2 instance types. There's 27 of them supported in RDS, but they really break down into three categories. You've got your T2 family, which is sort of affordable for performance. That's a burstable family. Your M family, and then your R family. Now, the T's are a great engine to start with. A great instance type to start with. They are burstable, so they work on the notion of CPU credits. So you get a certain amount of CPU credits, then you use them up. You will see a performance degradation as you're exceeding those credits. As you scale up in the T2 family, you're going to get higher performance as well as higher credit limits. They do have moderate networking performance. And just a note here, we recently introduced for all of the Amazon EBS-based engines support for T2 extra large and T2 2x large. So you can go up to 8 vCPUs with 32 gig of RAM. So a good sized T2 instance, very affordable. T2s are really good for your variable workloads, so where you're maybe not running, you know, continuously, or they're good for sort of intermittent workloads. They're also part of the T2 Micro is eligible for the free tier. So if you're just trying it out, you get a free T2 for a year to try out and test the service. As I mentioned, you do want to monitor, if you're using the T2, you want to make sure you're looking at your CPU credit metrics in CloudWatch. So go ahead and add those to your to CloudWatch and make sure you're not consuming all your CPU credits when your workload is at, you're running your workload fully. So the next step up is the M family. Now it has the same shape as the T2, right? It has the same memory to CPU ratio as the T2, so a good balance of memory and CPU. Goes from now 2 vCPUs and 8 gigs up to 64 and 256. So we introduced support for the M4 16X large, so the top of the M4 family. High performance networking with EBS optimization also in the M4 family. And so these are really good for production workloads where you want good CPU intensive. So if you're, say, running a big WordPress site, it's really good for the M series will do a really good job for you. Now the R's are just like the M's, except they have twice as much memory. So they go up to a half a terabyte of RAM up on the upper end, the R4 16X large. Once again, we just introduced support across the board for the R4 family for the EBS-based engines and as well for Amazon Aurora. And really good for query-intensive workloads. So if you're running something with high connection counts, query-intensive, things that are going to take up a lot of memory, where you're going to want to have a large working set, the R4 family is really good. We do recommend that if possible, you use the latest generation. So if you're running an M3 or you're running an R3, you might want to consider moving to M4 or R4. Those are going to give you the best price performance. You're generally going to get better networking out of the latest generation. And as EC2 introduces new instance types, they always do, we will support those in RDS. So we'll continue to move forward and allow you to scale up to those larger instances. Ultimately, the best way to do it is to try it out, to run your production workload on your instance type of choice, and then be able to see whether or not you're exceeding the resources, whether you have enough I/O, whether you have enough CPU to handle your workload. So the next question you have to choose with RDS is, which storage type should I choose? We support two primary storage types, two SSD-based storage types. So your general purpose storage is your sort of affordable storage type, similar to T2, and it has this notion of bursting, but instead of bursting CPU, you burst in IOPS. General GP2 and provisioned IOPS, IO1 storage, both go up to 16 terabytes. So we recently introduced, we upped the maximum from 6 terabytes up to 16 terabytes, so you can have pretty large databases now with the Amazon EBS engines. With GP2, the IOPS is determined by your volume size. So as you scale the volume up until about 1.3 terabytes, the IOPS that you're going to get is dependent on the size of the volume. So larger volume, more IOPS. Minimum of 100, and then when it's below 1.3 terabytes, it's actually going to burst up to 3,000 IOPS. So you're going to get that bursting. That bursting will eventually deplete your burst credits. So once again, you're going to want to monitor that. But GP2 is a great choice. We see some folks not sure about which one they want to use, but we recommend give GP2 a try. See if, especially on an over-provisioned volume, it'll probably be good enough for you. Now, our premium option is the provisioned IOPS, also called IO1. Once again, an SSD-based storage, very fast. I forgot to mention, and I'll talk a little bit about it, we now leverage Amazon EBS scalable volumes. And when I talk about scaling, that makes it really easy to extend your volumes, to grow your storage. Goes up to now a maximum of 40,000 IOPS. We upped the maximum recently from 30,000 to 40,000. So if you really have IO-intensive applications, you can now go up to 40,000 IOPS. SQL Server, because of it's running on Windows and basically it's only using one EBS volume behind the scenes, is limited to 20,000 IOPS, but still a good choice there. And what you're going to get with IO1 is consistency. You're going to get that consistent IOPS 99.9% of the time. You're going to deliver that. It'll deliver that to you. So high performance, high consistency. The third option is magnetic. We still have magnetic storage, mainly for legacy applications. If you're running an RDS instance for years and you want to keep it running, then you can choose the magnetic option. We don't really recommend it for new databases in the end, because with magnetic, you're actually going to pay an additional charge for each I/O, for each million I/Os that you perform. So most magnetic users actually see that they pay more than they would for GP2, and they're going to get a less consistent performance, and they're going to get less throughput than they would with GP2. So we really support that for legacy databases, but don't recommend that you use the magnetic storage. So I mentioned a little bit about this choice between GP2 and IO1, and how do you decide? How do you pick one? GP2 is a great choice. As I said, most people's applications, you'd be surprised that most people's applications really don't push that much I/O. And it's a great choice, and especially if you scale up past 1 terabyte volumes. Because what happens is, you can see from the chart, your baseline performance crosses over your burst performance. So you don't have to worry about burst performance. So if you're running a 500 gigabyte GP2 volume and you want more IOPS, just go ahead and provision it up, and it'll cost it's cost a few dollars more a month, but you're going to get much better performance, and it'll be less expensive than if you go to IO1. The burst balance metric is there in CloudWatch to determine your credits that are available. And once again, monitor your read-write IOPS performance to see if you're running above that baseline and you need more IOPS. The other question people get is, why am I not seeing 30,000 IOPS? I went into IO1, I provisioned 30,000, why am I not seeing that? Now, you really need to think about your IOPS rating as sort of the maximum I/O rate. This is the top end of the threshold. Your workload needs to push that much data. We find a lot of workloads don't actually push the I/O because of contention in the database, because the threads in the database are actually not doing all that I/O. Or you're actually using memory more efficiently. So you'll actually see your IOPS drop because you're using your buffers better, you're using your memory better. So more IOPS is not necessarily better. So once again, look in CloudWatch, look at your metrics, and make sure that you're really using the I/O that you're you're paying for. So scaling. So once you've picked your initial configuration, you've picked your instance type, how do you scale up and down? So if you've got additional load, you've got your application is seeing more load than you expected, you've got more users, you've got queries, you want to scale it up. So you can easily scale compute and memory, so you can scale anywhere up in the instance family, or you can scale to another instance family, so you could go from an M series to an R series to handle additional capacity. You can also scale down, so you can go to a lower instance class if you don't need all that capacity, you're overpaying. Now when we scale capacity, we create the new host, so we go to EC2, we grab a new host machine that we're going to run, we install the database on it, we get everything ready, and then we disconnect the original database, and then we reconnect the new database to the same storage and restart the database. So there will be some downtime when you scale storage. Your applications will need to know that, so they'll have to reconnect. They'll get a new IP address because the new host will have an IP address. The endpoint will be the same, so when you go to DNS and you get your IP address, it'll be the same endpoint, but you will have to reconnect to that new instance. So we recommend that you do a scaling operation in a time when you can afford a little bit of disruption to your application. Now storage scaling, as I mentioned, we now scale up to 16 terabytes of storage on the Amazon EBS-based engines. On Amazon Aurora scales automatically to 64 terabytes. So if you're using Amazon Aurora, that's has already been there. But for a lot of folks who are using Microsoft SQL Server or Oracle or Postgres, they wanted to go have larger volumes, so we supported that. The other thing that we did was we took advantage of the Amazon EBS elastic volumes. And this allows us to extend a volume very, very rapidly. So before, when you went from, say, a 2 terabyte volume to a 4 terabyte volume, it could take a long time. It could take hours. Now, your database was still alive. You're still active. You could still use the database. But what we were doing is we were copying over all that data to a new set of volumes and then switching over the instance to use that new set of volumes. Now, when we scale, we use the elastic volumes, and we simply extend the volume set for Amazon RDS. And just a note here, Amazon RDS actually uses multiple volumes behind the scenes, multiple EBS volumes. We present that to you as a single data volume. So you don't have to worry about volume geometry or any of this. You just sort of say, I want 8 terabytes, I want 10 terabytes, and we'll go provision that for you. So there's really no downtime to storage scaling once you've sort of done that initial scale. Now, if you've got older volumes, the first time of scale, it will be a little bit slower. We have to use the old technique to get it into a new volume configuration. So that does take a little bit of time. So if you're planning on scaling in the future, you might want to take that hit up front, and then later on down the road, you can use the elastic volumes and get basically instantaneous scaling. You're also limited in scaling to once every 6 hours. We do some optimizations, and so we basically keep you from scaling once every 6 hours. That could change in the future, but right now that's the limitation. So just be aware when you're scaling to make sure that you've got the size that you want. Now, if you're using provisioned IOPS, you can change the IOPS value on the fly without any disruption to your storage, so you can increase the I/O that you're using easily. The next thing people ask about is, how do I manage high availability? How do I manage backups? How to do all sort of the day-to-day tasks of running a relational database? So I want to first talk about high availability. As I mentioned, this is a feature that's typically in the enterprise version of a lot of our commercial databases, and we built it right into Amazon RDS. Our multi-AZ configuration provides that fault tolerance. We have an additional copy of your database running in a second availability zone. As you know, most likely, an availability zone is a logically distinct data center in the same region, so you get sort of that extra redundancy. You get automatic failover, so if we detect anything's going on, if we can't reach the host in the primary, if there's a networking problem, if there's some sort of infrastructure problem, then we'll initiate the failover automatically. All the data is synchronously replicated so that you don't have to worry about any data loss during this event. And it's super easy to do. You just turn on one button in the console and enable it. So it's not just enough to know that you have a high availability story, but what actually happens during a high availability story? You should test this. So it's great that you've set everything up, but do your applications survive some sort of networking event? Do they survive when a multi-AZ failover happens? So this diagram here shows you at a steady state, you've got your primary an EC2 host, that's the database server that your database is running on. You've got your set EBS volume sets, and then you've got a standby in an additional availability zone, number 2, and they're replicating synchronously. Now that replication is at the block level. It's not a logical replication, it's actually physically replicating the storage blocks. And there's a third party here that's monitoring these two and making sure that it can see both of them and maintaining the quorum so that they make sure that there's only one that thinks it's the primary and only one that thinks it's the secondary so that they don't get effectively a split brain syndrome. So once that observer determines that there's a need to failover, it loses connectivity, then it initiates the failover. The secondary becomes the primary. We put a new entry into the DNS table so that you can, your application, when it gets disconnected, queries the DNS again and then connects to the new primary. So you'll get a new IP address, reconnect to the new primary, and then you'll go. Typically, this process takes about a minute to 2 minutes to perform the failover. There will be some time when the new instance starts up on the new database starts up on the secondary. After that, then we'll reestablish a new secondary to make sure that we put you back into a highly available configuration. We'll start to repopulate the secondary, even if that secondary is on either the existing host or we have to go provision a new host. Now, one of the things that if you're caching DNS entries, if your applications hold on to IP addresses, then make sure that they respect the time to live value. You want a low time to live because when you go back and get a new IP address for the new primary, you don't want it to be stale. So please test this. If your applications simulate a failover, you can go into the RDS console and simply select reboot with failover. You just go to your instance, say reboot with failover, and then it'll initiate this, and you can see how your applications behave. If you're using connection pooling, make sure that the connection pools behave. So the next thing that you might want to take advantage of is read replicas. And so people say, why would I need a read replica? And read replicas, the primary goal is to relieve pressure on your source database. So you've got a writing node, you've got a main database, and you're finding that you've got extra traffic on there. And instead of scaling up the primary, you might want to create a read replicas to sort of offload some of that. Most applications are actually read heavy, not write heavy. So you can create an additional read replica. Another reason you might want to do it is actually using a global read replica, using a cross-region read replica. So let's say you've got a customer database in US East 1 that's being updated continuously, and you need a copy of that in US West 2 out in Oregon, because you're going to have a read-only copy, and you've got a front end in US West 2 that you want to present to your users, and you don't want to pay for the latency to go between across the country to go get data out of the database. So you can set up a read replica in another region. It'll populate that. It populates it asynchronously, so there's no lag time, there's no impact on the source database. Another reason you can use read replicas is actually promoting in case of a disaster recovery. So let's say in that same scenario, I'm on US East 1, I create a read replica in another region, and then something bad happens. I lose a database, I lose an application, the whole region disappears, which hopefully never ever will happen. But so in that case, you can populate, you can actually promote the secondary, the source database. Sorry, you can promote the replica to be the new source database, to be a new master database, and then use that for your applications and recover quickly. The last scenario is kind of nice, is you can upgrade the read replica to a new version of the database. So let's say you're testing out, you want to test out the latest version of MySQL or the latest version of Postgres, but you don't want to impact your working database. So what you can do is you can create a read replica, you can upgrade that to the new version, you can actually disconnect it if you want, and run your test on this new version so you get a full copy that you can run against. And then when you're ready, you can actually either promote that one or you can upgrade it, the source database. So lots of scenarios, lots of useful things around read replicas, supported for MySQL, MariaDB, and PostgreSQL. Amazon Aurora also has a notion of read replicas. It's a little bit different in that it works on a shared storage architecture. So instead of getting an actual second copy of the database, you just have additional reader nodes on the storage architecture. So this is for all of the EBS-based, EBS-based engines. So I talked about multi-AZ, I talked about read replicas, and you know, they both get copies of the data, so why would you use one versus the other? So I put together this just to sort of help you decide you know, which is right for your scenario. Multi-AZ is synchronous, so every block is written to both copies, both sides of the database. Read replicas are asynchronous, so there is potentially a replication lag depending on the distance between your source and your target, so you need to accommodate for that, you know, that lag between the source and the target. In a multi-AZ configuration, only the primary instance is available. So even though you have a secondary there that's waiting in case of a failover, only the primary instance is actually active. And then we switch over and start the database once it's on the secondary. In a read replica, all of the replicas are active. So you can use them for read scaling. They're full databases running, and you can use them for read scaling. For multi-AZ, we actually support the ability to take your backups. I'll talk about backups in a minute from the secondary, so reducing any sort of impact on the primary. Read replicas, you don't really need a backup because they're read-only copies. You can recreate them at any time. Multi-AZ is only 2 availability zones in a single region. So exactly 2. Read replicas could be either within a same AZ as the source database. It could be across AZs or across region. So you get that option when you create your read replicas. Versions, so when I upgrade a multi-AZ configuration, the version of the database upgrades at the same time. So both sides, because it's a synchronous copy, are upgraded simultaneously. That does mean that when you have a multi-AZ configuration, that we do have some downtime when we upgrade the database. When we go to a new version of the database, we will experience a downtime because we have to restart the database, reapply any of the changes that have occurred. Read replicas, they're independent database engines, so you can actually upgrade read replicas independently from the source database. And as I mentioned, that's a really good strategy if you're testing out a new database version with your application. And finally, with multi-AZ, you get that automatic failover. When we detect a problem, we automatically failover. Although you can promote a read replica to be a standalone database, that's not automatic. That you have to manually go in, you can write a script, you can go through the console, and you can promote that as part of your disaster recovery if you want to promote that. So in reality, we see lots of customers who use both, who use multi-AZ for their production database and then create a set of read replicas from that multi-AZ configuration. So backups are another thing that if you're running your own database, you have to spend a lot of time managing your backups and managing the backup metadata and making sure that your backups are good. And with Amazon RDS, it's built in. We have 2 types of backups in RDS. We have our automated backups. These are a window of backups in which you can do point-in-time restores. And then we have manual snapshots where you can go in, either using the CLI or the API, you can take a full snapshot of the database and store that for later. Now, RDS uses Amazon EBS snapshots, and those snapshots are stored off in S3. Now, they're not stored in your S3 buckets. They're stored in the RDS accounts buckets, and you manage them through RDS APIs. So you don't go to S3 and expect the snapshots to be there. We're managing on your behalf, and you access them through the RDS API. Now, in addition to support point-in-time restore, so point-in-time restore is the ability to effectively rewind the database to any time that you want within a period. So let's say something bad happened yesterday at 4. You can say, I want to rewind the database to yesterday at 3:55, and you can do that point-in-time restore. In order to support that, we store the transaction logs. So we take a full backup of the database every night, and then we store the transaction logs every 5 minutes, and we ship those off to S3. And then when you restore the database, we're actually going to replay those transaction logs and get your database back to the point where you want it to. Now, the nice thing about backups, because they're done by EBS, is there's no performance penalty for them at all. There's not any sort of load on the database server that you'll have. So you can take as many snapshots as you want. You don't have to worry about them impacting your server. As I mentioned before, you can see here in the diagram, we've got our availability zone 1. This is a multi-AZ configuration, and we're actually taking the snapshots off of the volumes attached to the host in availability zone 2 off of the secondary host. Transaction logs are then being pushed each 5 minutes into S3. Then you can then also take a snapshot and you can copy it across regions. So let's say you want to have, you want to store that snapshot in another region for disaster recovery. You can restore it later, or you just want to save the database at a certain point in time. We'll keep that around for you. So when should you use these different techniques? So an automated backup, you specify your retention window. It's super easy. It defaults to 7 days. You can get up to 35 days. And we'll let you do point-in-time restores to any time in that window. Manual snapshots, so you go through the AWS console, you select, I want to take a snapshot now, you give it a name, and we'll keep that forever. So automated backups will eventually leave the backup window. So if you have a 7-day window, anything after 8 days will be deleted and move out. Manual snapshots, when you take them, they're there forever until you delete them. So you can keep them around, you can keep them for years and restore them if you need to. Automated backups support that notion of point-in-time recovery, so a specific time during the day. And then manual snapshots restores to that exact snapshot when you took that full backup. So automated backups, I mentioned, good for disaster recovery, to getting back to a good state of the database, while manual snapshots, good for things like before you make a big change. If you're using a production environment and you want to pull that into test, so you could take a snapshot of your production environment, pull that into your test environment, and then run your tests against basically a copy of your production environment. Any environmental changes you're making, or maybe a final copy before you delete it. So we'll save one off in case you didn't want to delete that. So restoring a database. So how do you restore the backup? As I mentioned, there's 2 ways. You either do the point-in-time restore, as you can see in the top right, you specify the restore time, or you go to the snapshot, you say, I want to pull this snapshot back. Now, restoring creates an entirely new database instance. It doesn't affect the running database. So when I take a backup of my database and then I restore that, I get a new database instance, a new set of storage. It doesn't change the one that's running. So even if it's a point-in-time restore, that one's still there. So you'll get that new instance configuration. You can specify the instance type, the storage. You will get the default parameter, security, and option groups, so you might need to go set those after you do the restore. Now, some people say, why does it take so long? It can take, for large databases, it can take a significant amount of time for them to be fully restored. And the reason it does that is because the new volumes are hydrated from S3. So remember, we're storing the backups in S3, and what happens is that we make the volume initially available to the database. So we get the volume ready, but then the blocks are pulled in as they're needed. So they're pulled in from S3. And so when you're initially restoring a database and starting it up, it can be slow until some of those blocks come in. Now, we're working with the Amazon EBS team in order to pre-hydrate, to warm that quicker so that those blocks come in faster. But just be aware that when you restore a large database and you want to get that up to speed, it will take a while until you're basically pulled in all the blocks. Ways to mitigate that is to make sure that you've got an instance class with high I/O capacity. So if you're restoring something, you can use a larger instance than you might in production, at least for that initial restore, and then you could scale it back down. And then you want to maximize the I/O. So maybe you want to use provisioned IOPS or other ways to really maximize that I/O for the restore. So we also get a lot of questions about security. So how do I secure my database? How do I make sure that my data is secure in the database? We know that database is the heart of your company, and you want to make sure that it's secure. We've designed Amazon RDS to default to be secure by default, to be out of the box just as secure as you would have on your premises, or more secure. And that includes using Amazon VPC for network isolation, using IAM for access control, encryption through AWS Key Management Service, as well as if you're using the commercial engines, using Oracle or Microsoft Transparent Data Encryption, and then using SSL. So these are some of the techniques to make sure that your data is secure. So what does VPC do? You're probably using VPC today if you have a new AWS account, but it really isolates your database into a private subnet to make sure it's not accessible via the internet. So while you're in development environment, you might want to open up ports to allow direct management of your RDS database. But when you're actually in production, you probably want to turn off publicly accessible and just make sure that that database is only accessible by other instances in the same VPC, right? So other EC2 instances that can access that. So you'll want to make sure that you're managing your who has access to your database. But really that IP level firewall, opening up whatever ports you want to access your database. If you're working with instances in EC2 Classic, so if you've got an older AWS account, you can use things like Classic Link to communicate back and forth. And VPC also provides things like routing rules, direct connect if you want to connect to the database to something on premises. So for example, if you've got a database you want to replicate from on premises into Amazon RDS, you can do that through direct connect and tie those to your VPC together. Peering allows you to share between VPCs and gateways. So all features built into Amazon VPC. So granting access to your database. So we use identity access management to determine who can do what to your RDS resources. We encourage you not to use your root credentials to manage the database. You want to keep those root credentials safe. Assign roles to people or what they can do. There's set up templates so that you make sure that only people can create databases, delete databases. You want to set those rules up, including your sysadmins. You can also use the multi-factor authentication to provide an extra level of protection. So if you ever have an account compromised and you don't want a rogue actor deleting your RDS databases, you can use multi-factor authentication. It requires a token as well as a password in order to perform actions. And you can say, okay, you can't change the configuration, you can't delete sort of dangerous actions without multi-factor authentication. So that's managing the service itself. That's creating databases, instances, deleting them, setting security, setting properties, options. Now, once you've got your database up and running, then you access it, you grant access to tables, views, stored procedures within the database, just like you would today with an on-premises database. So using tools like SQL Enterprise Manager or MySQL Workbench, any of those apps will work today to provide access within your RDS database. That's just the normal grants that you have. Now, we do have a couple of ways to provide integrated security. So we do support for RDS for SQL Server, Active Directory integration, so you can keep your user directory in AD and then authenticate into your RDS database. We also support IAM authentication, where you can actually use IAM credentials for RDS MySQL and RDS Aurora and Amazon Aurora. So you can actually use IAM users to determine who can have access to your database. So there's some options there around authentication. Encryption is also a feature that you'll want to turn on. By default, I think it's off in the console, but I would encourage you to turn on because it's basically free. It doesn't have any performance implications. We encrypt at the volume level. So encryption at rest, the data is fully encrypted at the volume level. There isn't any performance penalty for encrypting the data. And we provide centralized key access through AWS KMS. So any access to the encryption keys is logged, it's audited. We actually use a two-tier encryption. So you can see here we have your master keys that are created or managed by you. And then each individual instance will have its own data key. And the master key is used to encrypt the data key, and the data key is used to encrypt the data. And this allows you to do key rotation, and it also helps from compromising keys, right? Because if you have to have access to the master key to decrypt the data key. Now, if once you encrypt a database, you can't unencrypt it, so it's a one-way door. You can take an existing non-encrypted database, and if you take a backup of that, so you take a full snapshot, you encrypt the snapshot, and then you restore that, you can get an encrypted database. But that does take a while. So I would encourage you, if you're going to use an encrypted database, go ahead and do that from the start. If a source database is encrypted in a read replica scenario, then the read replica is also encrypted. So they're both encrypted. And that includes both within the region and cross-region. So monitoring, how do you monitor the health of your instance? So people are used to using third-party tools to monitor. We have a lot of things that are built into Amazon RDS for monitoring. So your basic CloudWatch metrics. There's about 15 metrics that you get just out of the box. You go to the console, you go to CloudWatch, you'll see those metrics there. You can set alarms on those, so you can make sure that if you see a threshold, a certain I/O threshold or connection count threshold, you can set an alarm on that, and then you can get notification when that alarm happens. We have something called enhanced monitoring for Amazon RDS, and I encourage you to turn that on and make sure it's on. It gives you about 50 additional metrics that are not included in the basic CloudWatch metrics. And it doesn't really cost anything. It does use CloudWatch logs to egress that data, but it really, unless you're monitoring a large database at a high frequency, it shouldn't cost you anything extra. You can actually go down to 1-second intervals too with enhanced monitoring. We also have an integration with a lot of third-party tools. Now, that's CloudWatch, and enhanced monitoring is about monitoring the infrastructure, monitoring the basic operating system. We have a new feature called Amazon RDS Performance Insights. With Amazon Aurora for Postgres, we introduced this new feature, and what this does is allows you to look inside the database and see what's going on. So this is similar to tools that you may have used for commercial databases, where you can see what are the queries that are actually taking up the time. Why is my database slow? Oh, there's this query, and there's contention, it's locked on another set of queries that are running. So this was introduced. We introduced a new metric called average active sessions. So you can see here it's broken down by the different SQL statements that are running inside the database. You can see the top bottlenecks, top SQL statements that are causing bottlenecks. Super easy to drill down. We'll have an adjustable time frame, so you can see, was my database slow, last week or yesterday? So you'll be able to take a look at that. It's available now for Amazon Aurora Postgres, and it's coming to all of the rest of the Amazon EBS engines. So MySQL, MariaDB, it'll come for SQL Server, Oracle. So we'll have this functionality. And really, we want to make it so that not only sort of keeping your environment running is easy, but also managing the performance of your database is easy. So one final tip on monitoring: how do you know when something happens on your RDS instance? We use Amazon SNS to notify you when something happens. So for example, a backup fails or a storage full notification. So you can create a subscription for events right through the console, and then it notifies an SNS topic, and then you can get an email, you can get a text message, it can call an HTTP endpoint. So when something happens in your environment, you want to be able to be alerted. Things like what happened to an instance, if someone changed a configuration, if a backup was deleted, if an instance was deleted. So all of these will generate events, and you can specify which events that you're interested in through the console. So you should take really advantage of the eventing mechanism. Now, one popular question I get is about maintenance and about billing. Surprisingly, it's not about the technology sometimes. It's about how am I going to be billed, and how do I keep my bill low, and then how are you going to maintain my database? So from a maintenance perspective, when you create your instance, you're going to specify a maintenance window. That's a once-a-week, 15-minute maintenance window. And if we have any maintenance operations that causes downtime, now that doesn't happen very often. We try to, as much as possible, don't cause any downtime, but it will happen a couple times a year. But if it happens, it will happen in that maintenance window. So don't think that just because it's Wednesday night at midnight that you're going to get a maintenance event, you're going to have disruption. But if we do have a maintenance event, it will go in that window. Most of the operating system level maintenance that we do, most of the patching of the OS or patching of the RDS control software in the box is done without any database restart. Your database will keep running, serving connections, and we'll patch behind the scenes. Now, if you're upgrading the database to a new version, if you're going from a new version of Postgres or a new version of MySQL, that does require some downtime because we have to apply the new engine binaries, move and then apply any upgrade scripts to that. Now, minor versions are either automatically scheduled, so when you create your instance, you can say, I want to opt into minor version upgrades. So let's say you want to go from MySQL 5.7.10 to 5.7.19 automatically. So when we set a new minor version as preferred, then we'll upgrade within the next maintenance window. Major version upgrades are always manually applied, so those are up to you because they typically have changes to the engine that may cause application compatibility issues. So you'll want to see those. We do time to time also deprecate versions. So for example, if a version goes out of support or it contains bugs that are causing problems in the fleet that we've seen, we do deprecate versions. We'll always give you a notice when we deprecate a version, when a version is going away. For minor versions, we'll give you a 3-month notice, and then for major versions, we'll give you a 6-month notice. Those notices appear on, you'll get an email, but we all get a lot of emails. So they'll appear on your personal health dashboard as well. So there's a little icon up at the top of your console that has a list of maintenance events, and so you'll see that this database version is being deprecated, and it'll be an upgrade will be applied automatically within your maintenance window, but you will get time to plan for that. I do encourage you that if you get a maintenance notification from us, go ahead and plan that and do it. Don't wait till the last minute. We do hear from people who get to the very end and then, please pay attention to those. So from a billing perspective, bills are a little bit complicated, but they break down into 3 key pieces. Your database instance hours, right? So this is going to be depending on what region you're in, what your instance type is, what the engine you picked, and then if you're using a license included, Oracle or SQL Server, that'll be included in that instance price. So that's you're billing that in instance hours. Your storage, your provision storage for Amazon EBS or your consumed storage for Amazon Aurora, you'll get a storage bill that's billed in gigabyte months. Now, along with the storage, you may have some additional charges for if you're using provisioned IOPS. You'll be charged for the amount of IOPS that you're actually provisioned. And that's not a variable amount. So if you say you want 10,000 IOPS, you're going to be billed for that each period, whether you're actually consuming IOPS or not. Now, for I/O, for Aurora and for magnetic volumes, we also charge you in millions of I/O requests. There's an additional charge. And the final component is your backup storage. So it's the aggregate size of the backup that you've got that we're storing off in S3. Now, there's no charge for backup storage to the size of the volume. And what that means is that if you've got a 1 terabyte database, that means we'll store 1 terabyte of backups at no charge. And only when you go beyond 1 terabyte that we'll start to charge you per gigabyte month. A lot of folks who have larger databases but are using perhaps a small portion of them, they're using 2 out of 5 terabytes, will never actually see backup charges at all because they don't consume enough backup. The final piece is the data transfer piece, and that's similar to other services. There's no cost for transferring data into your Amazon RDS instance, so copying data in is free. Copying data out, so if you're doing lots of bulk exports, or if you're moving lots of data from region to region, so on the out you could see data transfer charges. Data within the VPC, within the AZ, obviously that doesn't count as data transfer. So a lot of folks never even see transfer charges. So on your bill itself, you're going to see relational database service. All the RDS charges are grouped by region. So if you're using multiple regions, you'll see those grouped. And then within that, instances are grouped by engine. And you'll see both reserved instances and on-demand grouped together. A real great tool, if you haven't used it, is the AWS Cost Explorer. It just got an upgrade, I think, last week. You can get a graphical breakdown. You can break down by instance type. You can break down region. You can break down, analyze your bill. It's a really nice tool for doing that. And then if you really want all the gory details for billing, they have the cost and usage report. That's a detailed line by line. Each hour shows you exactly what you're consuming in AWS and how you're being billed for it. You do have to turn that on. It's not on by default if you haven't used that. And it stores that in an S3 bucket. You give it an S3 bucket, and each hour it pushes out a very detailed cost report for you. If you want to bring that into, a lot of companies like to pull that in and bring it into their own database so they can do analytics. One thing you also might want to do is use tags. So there's a tagging feature in billing. So if you want to tag, say, your production resources or a department, you can set those tags on those resources, and then you can see in the bill analysis, you can slice and dice by tag. So another question, how do I save money on my database? One of the ways is through Amazon RDS Reserved Instances. So RIs give you a discount over on-demand prices, up to 60%, I think, for a 3-year reserved instance, and 30 or 40% for 1 year. Now, reserved instances is a little bit of a tricky word because we don't actually reserve capacity. So it's not like if I buy a reserved instance, there's a space on a rack sitting there for me. From an RDS perspective, it's just a billing commitment. You're basically saying, I'm going to run a database for a 1 or 3 year period, and I want to get a discount off of the on-demand price. We do now offer size flexibility. We recently introduced that. So if you're running for example, a R4 large, and then you want to scale that up to an R4 extra large, we now count the RI for the R4 large against usage of the larger type. So within a family for all of the open source engines and Oracle BYOL, so we do offer that RI flexibility. It allows you to get better RI utilization. We also recently introduced the RI utilization report. So this has been working a while for EC2, and it tells you of the RIs I've purchased, how many are being utilized and how much. So this worked for EC2. It now works for Amazon RDS as well. So you can go in there and see, okay, how am I using against my reserved instance. They also have something called the coverage report, which is of the on-demand usage I'm using, which is covered by RIs and which is not covered by RIs. That report will be working for RDS very soon now, so that's coming soon. So that really allows you to analyze your usage. And then the final thing is a way to save database is to stop it when it's not in use. We recently added the ability to start and stop a running database. So you can go to a database, you can say stop. While it's not running, you're not paying for that database. You're only paying for the storage that's being used. So it's available today for single AZ database instances. We mainly focused on development and test environments where you've got developers who go home at night, don't use the database over the weekend, and you don't want to have to pay for that database while it's not being used. Now, if you leave a database asleep for more than a week, we'll actually restart it because what we need to do is make sure that you haven't passed any required maintenance. We don't want to build up a set of patches over time. So we'll restart it, we'll reapply the patches. You do get an event when that happens. If you want to put it back, stop it again immediately, that's fine. You can stop it after it's done its maintenance and if you want to. So super easy, just stop from the console, or you can script the stop through the API. So hopefully this has given you a tour of Amazon RDS, lots of tips for optimizing RDS. In case you broke down some of the other related sessions at reInvent, I know there's hundreds of sessions, so these are some that you might be interested if you're interested in learning more about RDS, whether it's running SQL Server, running its Oracle, and some higher level presentations about overall database trends. But thank you so much for coming, and I will actually, I'm going to get off the stage, but you feel free to come up and talk and ask questions, and we'll also be at the show floor. So thank you very much.